Hi everyone. So as usual, we are on the Terraform, and this is the day 14th of the Terraform. So till now, what we have covered all these file creation over the laptop. I have passing variables value, Terraform data and output block, Terraform state file, dynamic block in the Terraform, EC2 instance creation, VPC creation, conditional resource creation, RDS creation, or the most important question which comes in your interview, what will happen if you delete the state file, correct? How Terraform will behave. So all these things has been covered till now in our 13 days, modules, functions, everything. Today I'm covering policy creation using the Terraform. Like when you are working with your AWS services, so you have to create your IAM roles, IAM policy, correct? So when you do that, you have to create different kind of policy. Correct. So there is some challenges which you have to face in between, and you have to create the policy with the help of Terraform, correct? When you are deploying the whole complete infrastructure itself. So we will see that part, and we will directly move into the code. So as usual, I have already written down the code so that I can save your time, and we will understand more on the logic part rather than writing the code in front of you, correct? That we can do later on as well. So what I'm trying here, I'm trying to create one KMS key policy, correct? For that, I will have to create one KMS key as well. So there is challenges in writing the KMS key trust policy, correct? So you have to define like one AWS managed policy or the customer inline policy. Here we see in the IAM service, correct? When you open this AWS IAM service, you will see there are many options. Like you can create IAM roles, you can create IAM policies, correct? So these are the kind of policies. So either you can create your inline policy, customer inline policy, or you can have the AWS managed policy. So as of now, you can see all these are the AWS managed, correct? So either we can have the AWS managed or we can create the customer inline policy, correct? So we can create according to our use case. So this is one of the thing, but there is other thing as well, when you create any kind of role, so that role will be having some kind of your trust policy. Just like I'm opening this AWS service role for SSO, correct? So it has policy attached with it, then it has the trust relationship as well. So for the KMS key, I have to create the trust policy as well. So this is the different kind of policy, correct? Trust policy, and this is the permissions given to this role. So we will cover these two things. So there are variations. That's why I'm focusing on these two, permissions and the trust relationship. So how can you pass the variables in this trust relationship, that we will see. So let's focus on the code side here. So this is one of the data block template file. This is the way of writing a trust relationship policy, correct? So this is the data block with the name template file, and this is the alias for this template file, KMS kit trust policy. What I am doing, I have created one file, kmspolicy.json.tpl. So this is the format .json.tpl to create your policy, where you can define your variables, and this will be treated as your trust policy, correct? So I have defined template equal to file. This is one of the function file. We have covered the functions concept as well in our previous video. You can watch out on the channel. And then there's a path.module. Path.module locates the folder or the directory where my particular file is. So it will search for the KMS policy.json.tpl, correct? This is the file KMS policy.json.tpl. So it's just in the parallel, correct? Then these are the variables what I will be writing down in this KMS policy.json.tpl. So what are the variables? It's customer name, customer environment, microservice name. This is MS name, that means microservice name, and deployment account. You can pass your own details, correct? So all these variables I'm using in the policy json.tpl. Earlier, so till the time, how we have declared the variables, correct? Wherever we have to define any kind of variables, like this KMS key require any kind of variable in the description, correct? So what I'm writing, customer KMS key for then the customer name. So whatever the customer name will be there, just suppose that it's the name customer KMS key for, or custom KMS key for the demo. That's our customer name, correct? So here, what's the format? We are writing as where.customer name, then where.customer environment, then where.microservice name. This is how we are writing, correct? But while you are defining in the KMS policy.json.tpl, you are not writing anything as a customer name, var.customer name or var.customer environment. We are directly writing the variables name itself, correct? And from where these variables names are coming, these variables names are coming customer name, customer environment, microservice name from here, correct, in the left side. So if you can see in the template file block, we have declared one block of the vars as well. So here, this is the vars which is come, these are the variables names which are coming from vars.tf, correct. Here in the vars.tf we have declared these five variables: deployment account, customer name, customer environment, microservice name, and deployment region. For all these variables, I have given the default value. You can have your own value which you can pass at runtime, correct. So these variables are in the right side, customer name, customer environment. That's why it's coming as a var dot customer name, and whatever the key is in the left side. For like the customer name, I can have this customer underscore name as well, correct? So if I change the value, if I do it as a customer underscore name, I will have to give the same customer underscore name here in my left, like whatever there was in the left side, that should be passed in the policy.json.tpl, correct? So this is how you can have your trust policy, where you can define your different variables, and with the help of that you can configure your policy, correct. So here I'm using customer name, then I'm using customer environment, then I'm using microservice name and the deployment account, correct. All these value has been declared here without any var dot, correct. Because this template file resource block itself says that you can define a vars block, and whatever the variables you want to use, you can give the value in the right side, and then these values can be picked up. Either you can write it in the main.tf, or to make it more configurable, you can write it in the vars.tf. But whatever the key is in the left side, the value will be passed in the kms policy.json.tpl or any of the file .json.tpl, correct. So this is one way of defining your trust relationship and configure that. We are using multiple functions as well here. Like here we use the file, then we are using the lower function to lower down the microservice name, correct. Then this is the resource for creation of KMS key, where we have the deletion window is 7 days. It's enabled. Enable key rotation is true. Multi-region, that means our KMS key will be multiple available in multiple region. And key usage, encrypt and decrypt, that we will do with the help of this. These are the tags you can see. And then we are more specific to IAM roles and policy as well. So the first part describes about the KMS key creation and the trust policy related with the KMS key, correct. And then the second part in this video only covers the IAM role creation and the policy which can be attached with the IAM role. So what we are doing, I am creating one role with the name IAM for Lambda, correct. You can see, and the role for Lambda, that's the role name actually. And here this is the alias IAM for Lambda, correct. So this is the role, and this will be the trust relationship, you can say. And this is the trust relationship for this like AGM role policy, correct. You can see AGM role policy, that is the that is called as the trust policy also. So this one, this will be the part of the trust relationship. You can see this AGM role policy, correct. We just saw that trust entity. What's the effect, principal, action, then action, STS, AGM role, correct. So in the similar way, we have written down here, and I'll be attaching few of the policy with this role for Lambda, correct. For that, I am selecting two of the AWS managed policy. So these are the AWS managed policy which have the full executions permission. So for this, I am using the data resource so that it can be directly uh, fetched from the AWS console itself, from the AWS service itself. And these are the names for this policy. And I'm creating two customer inline policy as well. So I'm creating customer managed policy one. Here I'm giving the all the details like action, resource, and the effect allow, and the permissions over the EC2 instances, correct. And then I'm having the customer managed policy second, and where I'm passing the name and the path and the description IAM policy for secret rotation from a Lambda, correct. So these are the kind of policy you can configure, you can create, and you can pass on the different actions, correct. So I'm passing secret manager, describe, get, put, secret update, any of the thing, whatever you want to, correct. So these are the details. And then once you have the created your AWS IAM role. So here I have created the first resource for as a role, IAM for Lambda. Once you have created that, then I am creating two of the AWS managed policy, then two of the customer managed policy. Once you have the role and policy created, now you have to bind these roles and policy together so that it can be work for giving any kind of permission, correct? So then AWS IAM role policy attachment comes in the picture, and here whatever the policy we have created, correct, till now. So we have created this secret protection.arn, then these two of the data resources, and then AWS IAM policy, customer managed policy 1.arn, correct? So these two we have created. So now we will try to configure this, correct? So we will run this as a your roles and policy, correct? Let me search it. I don't think I have created this secret rotation. Okay, so I have not created this policy anywhere. So let me just remove this. Control S, and let's run the Terraform init. Terraform init. So now initialization has been done. Now let me run the Terraform plan. And as usual, it should go get into AWS account and it will create all the resources. So few of the okay, we have got few of the errors. Customer environment has not been declared. This will ever can declared with a variable. Customer environment is not declared. It's declared. Customer environment is there. 102. AWS IAM policy 102. What's the line of error? Okay, seems like it is not saved. Let me save it. Let me do the Terraform plan again. Seems like this all the changes were not saved. That's why it turned into error, because all the variables are already declared and the main.tf is using the same kind of things. Okay, now let's see what's the error now. Invalid for each argument 5 to add. Okay, resource AWS IAM policy and Lambda policy attached. To set string known only after applied, the for each set includes delivered from resource attributes that cannot be removed until applied. Since or determine when working with the unknown values for each, it's better to use a map value where the keys are defined statically in your configuration. Okay, map value. Okay, so I'm just stopping my video for 1 second and I'll be back. So back to the video. So to the that particular problem, what we had, like we saw that we had the issue that all this policy I was trying to add in the same file on the same resource block actually. So but the thing was that this for each was not working because the value was not known, correct? So it was not working with the policy for which I had to generate the ID. There is Terraform, it has to generate the ID after the apply, correct? So either I had the options to use the local variables, or I had the options to run the Terraform apply twice, correct? So rather than doing that, what I have done, so for the policy which are already AWS managed that has the IDs, for that I have run use this for each block. And the for policy, what I am creating as an inline policy, for that I am creating two of the uh, resource block for the IAM role policy attachment, correct? So Lambda policy attach one, Lambda policy attach two. That's what I'm doing. Now, when I have done the changes, and now if I run the Terraform plan, you can see. So it's 9 plan to add, correct? So you can see this. Let me cancel this. And customer managed policy one is being created. Now you can see customer managed policy two, and then AWS IAM Lambda or role that is being created. These are the resource block and the Lambda policy attach one, Lambda policy attach two, KMS key. Everything is being created. Now let's run the Terraform apply and we will see the changes. Terraform apply auto approve. Auto approve, correct. Let's do the changes and we'll verify over the AWS console itself. So all the things are being applied, data resources are running, and creation has been started. Few of the creation has happened, and few of the permissions are not there. That's why KMS key creation has failed. Creating IAM policy, the policy failed legacy parsing. Okay, malformed policy documentation, secret manager. Okay, so let's give the permission of the KMS key first, and we observe the creation of the IAM policy. So let me attach the permissions to my user, that is the demo user. And to this demo user, I will give the permission of KMS key. So till now, it does not have any permission to create the KMS key. Let me give that permission. Attach policy directly. Sorry, KMS full access. KMS provider key management. AWS key management service. I have to give the read power user. Let me give the power user for now. So it can create, delete everything, create a list, correct? So let me give the power user, add permissions. Let me create the resources, Terraform apply, auto approve. And what is the request? The status code 400. Malformed customer managed policy 2. It has the policy failed legacy parsing. Enabling KMS key access denied accession user demo is not authorized to perform KMS enable key rotation. Okay, so let me do, I will just remove this KMS key enabling for now is enabled false. Let me uh, auto rotation false and is enabled false. Let me put that. Control S. Multi-region also let me remove this. False. And alias we want. Uh, okay, let's have the alias as well. Let me do the Terraform apply. I'm just trying to solve this issue on the screen itself. That's why I'm not stopping the video. Otherwise, I can stop the video and I can create the things correct. So let's try to resolve. One to destroy, four to add. Okay, deleting KMS key, operation error, schedule key deletion. Okay, so it can not delete. Let me change the name for the KMS key, and name will be DB caps key, DB caps key, correct? Everything will be changed now. Control S. And let me stop the video just for 1 second here. I have again started the video and I've just made the changes. And the changes are very simple, what I was trying to do. So I have changed the name from the small case to uppercase. And now let's run it again and let's see what happens. Based on that, we will try to fix it again, correct? So let me clear the things and run the Terraform apply. Okay. Let's see whether it will be done or not. Read completed. It's stating there, sorry, refreshing the state and 4 to add, 1 to destroy, deleting KMS key that has been skipped. Okay, no issue. We don't want to delete and new KMS key should be created, I think. Or anyway, we will do the forced deletion will won't be happening. Okay, let's see on the console about other things. So one role we had created for the IAM for Lambda. So let me search. Let me refresh first. Refresh the browser. And the role was role for Lambda. Role for Lambda, correct? This one was the role. So this role has been created. So there we had this code. written over here. Let me close this terminal. So we had this role for Lambda. And in this role, we are attaching two of the AWS managed policy, AWS Lambda basic execution role, AWS Lambda VPC access execution role, and then two inline policy, customer managed policy one, and the name of the policy was Secret Manager RDS PostgreSQL. This is the strong, long name, and this the second manager RDS PostgreSQL policy 0. So these are the two policy we had created and attached this policy with the role. So let me see, there should be four policy. Yeah, two of the AWS managed policy and two are the customer managed policy, correct? So you can see the details. You can expand it and you can see the details that we have passed, correct? And the trust relationship, it's already there. What we had measured, secret manager and Lambda, correct? So in the code, if you see, while creating the role, we had mentioned that Lambda is AmazonAWS.com and the secret manager AmazonAWS.com. So this part is covered. I am role for Lambda and the policy. Now let's check into the KMS key. What has happened? One KMS key should be created, and that is in the deletion phase. That's why it's not able to delete. Yeah, so you can see that it's enabled, status is enabled. And what's the alias we are creating for this? Oh, what's the alias? DB capital key. Okay, so let me do one thing. I will just change the resource name here. I will change as a KMS key, and this will also be the block itself will be KMS alias, and the name of the resources will be db underscore capital KEI. Caps Control S. Let me open the terminal, run the Terraform, apply again, auto approve. Let's see. KMS key.id is not has not been declared in the root module. Target key ID. Okay. Line number 33. Target key ID. Yeah, I will have to change it to KMS key. What was the resource KMS key? So I will have to give the same thing over here, correct? Sorry, not from here. I will have to change it over here, KMS key. I hope you understand the changes. So I'm passing the target key ID as the name, the resource of this, correct? AWS KMS key dot KMS key, and then the ID key ID. So I had when I have changed the alias for this resource, I will have to pass the same over here as well. Disabling KMS key, operation error, KMS disable key, HTTP response code, two to add, one to destroy, access denied. So this particular user demo does not have access. Okay, I have given all the access to my user. This demo, let me see if it does not have access or which kind of access it required. It has a power access, correct? I will have to change or I will have to create one access as a KMS star. So let me do copy JSON. I will create inline policy. I will click on the JSON. I will just change it. And here I will just remove everything and I will do KMS star. That's fine. Let me do the next. KMS. I'm just adding this KMS inline policy. Create policy. Okay, now this role has, sorry, this user has the access of doing that. Let's try doing the same kind of operation now. Terraform, apply, auto approve. So what I have done, I have given the access to this user demo so that it can perform any kind of action over the KMS, correct? So I have marked it as KMS and the action as a star. Let's see whether it works or not. Destruction completed. Now KMS key is being created. Let's see. Two of the destruction has been done. KMS key is still creating. Let's see what happens. 10 seconds elapsed. Let me get into the KMS key. Okay, you can see pending deletion. So two of the KMS key are being disabled, like they are being deleted, and one has been created, which status is disabled for now, and alias is still to be created. So two destroyed, two added. Now let's refresh, and I think it has been created now. So you can see the alias has been created, db key underscore demo production main, correct? This is the key ID. And the trust relationship, what we have configured, ARN AWS IAM root, correct? So these are the details what we wanted to pass, and the things has been created. So this is the customer managed key, db key ms, correct? So all the details what we had passed, key rotation, everything, you can configure other things as well, correct? So we have created this alias, then the key policy. So you can see the details over here, correct? So this is all we wanted to discuss in this particular video. And thank you for watching the video. We will come up with next topics and next details in the next video. Thank you.